In this session, we are going to learn about dilation. This is also one kind of morphological transformation. In the last session, we have seen or we have actually implemented erosion process in OpenCV using Python. Now, this dilation, what happens that this is just opposite of erosion. Here, a pixel element is 1 if at least one pixel under the kernel is 1. So what happened? It increases the white region in the image, or you can consider the size of the foreground object increasing. Normally, what happens in case of noise removal, erosion is to be followed by dilation. Why? Because erosion removes white noises, but at the same time, it also shrinks our object. So after the erosion, what we do is to dilate it. Since noise is gone, they will not come back. Okay, they will not come back. So what happens? Our object area will increase. It is also useful in joining the broken parts of an object. So in short, we have to say that when we go for noise reduction, first apply erosion, and we apply erosion to remove the white noises, right? Then after that, what happens? Since this object from which we remove the noises, its size will be shrinking. So apply dilation. And when we apply dilation, that only that object, or you can say the foreground object size increases, because noise once gone, it will not come back. Well, let's try to implement this in Python. I'm going to open Spider for this. So you please open OpenCV. So you see here, okay, import CV to SCV. I hope you know already. We have discussed a lot of time that what is CV, right? OpenCV. We are importing CV to SCV. Now import numpy as np. Then this is the location where the image is there. Then this, if this is not found, then this message file could not be read. And now we are designing a kernel. Kernel is our 5 cross 5 matrix. All values are 1. So NP wants 5, 5, and P, the values are the type UINT 8. Right. Now erosion, in the last class, I show you that how we are implementing it, just using this erode function, passing the original image, then kernel that we have just defined here, 5 cross 5, right? Then iterations 1. Now dilation is what? We are going to use dilate function, cv.dilate. Same thing, pass the original image, img, kernel, just we define, and iteration 1. Plus you remember dilate, D-I-L-A-T-E, this function. Now after this, first show the original image, then show the eroded version, then show the dilation, then wait key 0, so that if we click the close button, then the image will be closed, right? Window will be closed. Then after that, we are destroying all windows. CB destroy all windows for memory. Well, so now you got each and every line of the code. Okay, let's then run this. First, let me clear this. Okay, clear. Then, okay, then go for running this. Well, what we have got, this is the original image, right? This is the original image. Then this is the eroded one. This is the eroded one. So original image size shrinking, object size shrinking in the eroded. Now let's see the dilated one. Dilated one is this one, right? So what you can do, here I am applying this dilation on the image, original image. You can do it on the eroded version of the image also, right? Well, for that, I have made a little sense here. See, in this case, dilation, CV dilate. Now, instead of the passing original image, just pass here erosion. Okay, erosion means this one. which one is the eroded version of the original image we have got in this line. So I have passed erosion here, then everything is same. Now let's run this code. Well, now original image, this one is the original image. Okay. This is the eroded version of the original image. Then this is the dilation or dilated version of the eroded image. Well, so it is clear now. Just don't skip the practical. If anything more you want to know on this morphological operation part, then let me know through comment. Thank you.